video, I want to introduce you to Julius AI. Julius is a AI system, AI chatbot for data analysis, essentially. So I kind of want to introduce you to it and walk you through it analyzing some data from our world in data. It's COVID-19 data from that. If you're getting started with your research, don't forget to download my 30-day research jumpstart guide. It kind of helps you learn your field and generate a plan for that research so that you can do data analysis and potentially use something like Julius. I will also have a link to Julius in the description below. So I'm gonna come in here. This is Julius AI. Just to give you a feeling for it, there are several different things you can do. So if you type the forward command, you can see there's different types of commands. So there's data, search, text, media, and HTML. We're gonna do quantitative data analysis here. And I'm gonna go ahead and add a file and I'm gonna upload. So the file I'm uploading is from Our World in Data. It's a public repository of a lot of different data. And this is COVID-19 data. So it has things like total cases per country, per, I think, week, things like vaccination rates, stuff like that. And then we can also control AI settings. So you can see, you can select the AI. So you can use 3 different AIs here, OpenAI GPT-4, Anthropic Cloud, and Mistral 7B. I'm just gonna leave it on OpenAI and it kind of tells you what it's good at. So this would be a really good one if you're going more qualitative. If you wanna do text parsing, document summarization, I would switch it to that one. And then Mistral 7B is strong for benchmark performance. I think OpenAI is good for what we're trying to do here. And then personalization, let's say this is a healthcare one. And so it is going to insert general instructions here. I don't really like its general instructions. I'm just gonna leave it like that. And then it has a compassionate tone and the language is English. And I think all of that's fine. So I'm just gonna click save there. So we've saved our AI settings, we have our data. And now what I want to do is I want it to please provide a line graph of new cases and vaccination rates over time. Let me correct my spelling on vaccination. And I'm gonna click send. Okay, so it gave me this graph. Let's open this up. I don't see a blue line in here. Oh, there's the blue line, okay. What's interesting is that our vaccination rate is going like, it's both positive and negative. This data looks very, very weird to me. So if I look at show code, it looks like there it goes. Okay. So this is what I do like about Julius. Instead of it just doing the analysis, it's giving you the code, but this is specifically Python code. And the reason I think this is so important is because you do not want to take an analysis without knowing how that analysis was generated. So you don't want to be like, is this significant, without knowing how that, how it's generated, especially if you're going to use it. You shouldn't be just using analyses created by AI when you don't know how that analysis was generated. So what you could do is take your data and import it into Python using Jupyter Notebook, using any other like RStudio, any of your IDEs that you want, and then take this code and reanalyze it. That also means though that you really want to be able to know some level of Python, and maybe you even learn it through using something like this, but you want to know something to know what it's actually doing. So you can see here it's reading in the data. It's checking the head to make sure it knows the columns, what data types they are. So now it's grouping by date and it's aggregating the new cases by sum, and the total vaccinations is the sum, and it's resetting the index. So it's converting the date to date time. That makes sense. And then it's taking the grouped database and it's sorting the values by date. That makes sure that they like line up correctly. And then we're plotting the figure. So this is using matplotlib. Yeah, so it imports matplotlib up there. And it's creating a plot of the date and the new cases. since vaccination rates are cumulative, we need to calculate the daily change to get the rate. That's how they got negative values. Okay, so I need to check to make sure that the vaccination rate is cumulative and that there wasn't a column they could have used, because I think that is what threw this off so much. Because this line we should see a higher blue line. Like this got thrown off. The actual image generated wasn't accurate to the data. But we can see group sort values, and then they're plotting that vaccination rate on the previous plot. And then they're just adding information here. So you can actually like take this data and run it and kind of see what it is, and then be able to play with it and generate kind of a better plot than this plot that is happening there. But if you're trying to quickly analyze some things to kind of figure out what your story is with your data, you could use Julius to start generating some initial plots for you so that it's a little bit faster, especially if you don't know if those are going to be your final plots, and then regenerate all that data, all of your plots using their code and then editing it for what you want to do. So let's look at how well does it do with, let's look at a statistical analysis. So using the previous data, are the vaccination rates in different regions significantly different? Normalized to the accounting for the population is what I'm going to say. So I'm being careful not to give it too much information, especially if you don't exactly know what path you should take. You might not be able to just say, hey, run a t-test or run an ANOVA on this. So I'm giving it kind of general because I want to see how well does it do a statistical analysis. Okay, so what it's showing is the statistical analysis comparison of vaccination rates across different comments. Here's a summary of p-values obtained from the t-test. So the issue with the t-test here is that they had to do a lot of t-tests to generate this, which means our false discovery rate goes up when we're doing lots and lots of t-tests. So here I would have preferred that they did an ANOVA to compare these different continents to make sure that the interaction is specific, especially if you're just going to compare all these different ones to each other, and then do post hoc tests to kind of allow for that FDR correction there. So it's saying Africa versus different continents. So it's basically looking at each set and comparing it. So there's a significant difference between the vaccination rate in Europe and North America, and it's giving us the p-values there. So again, this is really nice, but we can also look at the show code, because if something's wrong in the code that they're generating, then something's going to be really wrong, and you don't just want to use these p-values. You want to be able to take the code, run it yourself, make sure that it's actually working correctly. So they import in a bunch of libraries up here. They import in the data here. Then they look at continent vaccination rate. So what they're doing here is they are creating a new one that's a new vaccination smoothed per million. So it's taking into account daily vaccinations and the populations. And so then they're pivoting the data to have the dates as the index and the continents as the column. That makes sense because all of this would be like date continent, and you want it to be date with all the different continent information to be able to compare across columns. We're dropping any rows with NA values. So that's again something that you may want to change. They're just dropping missing data. You may want to impute that missing data. You may want to do different things there is more accurate. They're just making an assumption here that you want to drop any data that's missing an NA. And then we're performing t-test with between the pairs of continents. So this, they set up a for loop. And again, in here, I would instead have done an ANOVA and then done a post hoc test. So they have their continents as the different columns. Their p-values is they're creating a data frame here with the continents, continent on as a row, and then continent as a column, and then your p-value would be at the intersection of those two. And so what we're doing is for continents 1 in continents, and then for continent 2 in continents. So how this will work is you're going to basically run through this. You're gonna, like, let's say the first continent was Africa. You're gonna set that one as Africa, and then the next one you're going to run through all the other continents as continent 2. So if continent 2 is Africa, because again, that's the first one, we have this to say if continent 1 is equal to continent, or if continent 1 is not equal to continent 2. So if those two are the same, if continent 1 is Africa and continent 2 is Africa, we're not going to do anything. We're going to go ahead and move down to the next one. Let's say continent 1 is Africa, continent 2 is North America. Now we're going to do this, which is perform an independent t-test here, and then save the p-value of that t-test to this data frame up here. And then we're going to keep running through it. So that's what it's doing here. And I have done t-tests like this, but it is also in a situation where I really want to compare two things to each other. You always want to think about your research question. If I'm just trying to say, are vaccination rates different across different continents? A t-test like this is not the best statistics to perform that. If I want to specifically say, is Africa different from North America because of this reason, then a t-test would be appropriate to perform that, even if I have the data to compare the other ones. So again, it is a little bit more specific on your actual research question that you're asking. You always want to have a research question before you're trying to do a statistical analysis so that you ensure your statistical analysis is correct to your research question. So I think Julius is actually a really good platform. I really love that it gives you the Python code to run. I don't know if you could ask it to run it in different code. I think it is specific to Python. You might need to know Python before you try and go really in depth, or at least start learning it through this, start figuring out what these things mean. Again, I would be very cautious of taking anything created directly by AI and using it directly. I would always double check anything that you're using with AI, but it's really nice because you have the code. Like this would take me like a couple minutes to double check because I can just copy this code, paste it, and then be able to alter it as I need it as well. And to clarify what the AI is doing, make sure it is analyzing correctly and that all these numbers are generated correctly. I hope this is a helpful introduction into Julius. And don't forget, I will have a link down below if you are interested in this software. On the free version, you do get, I think, 15 chats per month. And then after that, there are different levels with different numbers of chats that you can get from there. If you have any questions about this, leave it in a comment down below. And I hope you enjoyed this video, and I look forward to seeing you in the next one.